and welcome to an algebraic video getting into the concept of direct variation. So direct variation gets into this idea in mathematics that we are very interested in trying to quantify how things change and affect each other. So if this changes, how does it affect that? And can we measure that? Can we quantify it? Can I graph it? Can I put it into an equation? Can I represent what is happening in the world around me with numbers? It's very awesome and it's very tricky and it's very can be very complex sometimes. But direct variation is the simplest way to think about how does something affect something else. And so I really want to introduce this concept well to you guys. So let's think about what we have here. So I know that if I ride a bike longer, intuitively we know that we will travel farther. We're going to go a farther distance. So those two things are affected, right? Riding longer, I travel farther. I also intuitively know that if I'm at the library and if I add more books to my bag, well, what is the direct result of that? My bag gets heavier. So there's another example of things changing. Part-time job. If I work more hours, if I work more, I get paid more. I get a bigger paycheck. So we kind of intuitively know how things change. If I do this more, I get more of this. There's all these relationships happening around us. And I want to take, like, for example, these three ideas about bikes, books, work, paid. There's ways where we can turn those relationships into an equation. All right, so let's look at what a direct variation equation is. This is what it is in a nutshell. It says there's something changing x, some variable that represents, it could be hours, it could be number of books, it could be how much I'm working, but as that variable changes, it affects the result for this other variable, y. I go farther, my bag gets heavier, or I get paid more money on my paycheck. They're related, and they're directly related, and we show the equation by my y value is equal to some constant k, we'll get more into what k is later, multiplied by this other variable, this independent variable x. As x changes, it's multiplied by this value k to get some result for y. That is a direct variation equation. They all fit that form. Y equals some value k times x. So let's fill that in here. Y is just my dependent variable. Because it depends on whatever I'm changing x to be. So y always follows whatever I make x. So it's dependent on whatever x value I put in. K is my constant of variation. And x is my independent variable. It's just going to change, and I want to see how y changes as a result of it. All right, now let's just play around with a real example just to help us give something tangible that we can chew on. I'm going to take this riding a bike longer. Let's kind of play around with this. Let's say I can ride my bike. I go on a bike ride and I go 12 miles per hour. Let's put that into a direct variation equation. If x in this case is going to equal the length of time, how long I ride, my value for y will equal the distance that I travel. And so my direct variation equation, the distance I travel, y, is going to equal 12 miles per hour. There's my constant. I'm going at a constant rate of 12 miles an hour. I'm going to multiply that by however long I go on my bike ride. So there, we just wrote a direct variation equation for our bike ride based on how long am I going to ride my bike and how far I'm going to go. And we can play around with this, right? So what if I go 2 hours, that means I'm going to put a value of 2 in for x. X is my time. 2 hours at 12 miles an hour means that I travel 24 hours. There's my value for y. My 24 miles that I travel is directly related to the amount of time that I went riding. I could also think of it this way: if I go 0 hours, so I haven't even left. I'm not even traveling. So how far do I travel if I actually go 0 hours on my bike ride? Well, 0 hours at 12 miles an hour, I'm not going to get very far because I'm not spending any time going 12 miles an hour. 0 times 12 is going to be 0. I haven't gone anywhere yet. So this whole relationship between distance and time on my bike ride is definitely quantified and shown in this equation here. Y equals k times x. So hopefully it's a good introduction to thinking about, we have two variables, have x and y, and they're related in this way. And there's lots of situations around us that fit a direct variation relationship. And so in the next lessons, if you keep watching some of the videos I'm going to make, we're going to dig more into this, talk about how to set up an equation, how to graph an equation, how to use the equation to solve problems or think through situations a little better.